In this topic, we are going to look at the scalar multiplication of a vector. A scalar multiplication of a vector A changes the magnitude and or the direction of the vector. For example, k multiplied by vector A. If k is greater than 1, the scalar multiplication will increase the magnitude of vector A. For example, 2a will double the magnitude of vector A. If k is between 0 and 1, it will decrease the magnitude of vector A. For example, half a will reduce the magnitude of vector A by half. If k is equals to 0, then we will have a null vector. If k is between 0 and negative 1, for example, negative half a, this will decrease the magnitude by half and it will change the direction to the opposite direction. If k is less than negative 1, this will increase the magnitude and change it to opposite direction. For example, negative 2a means that the vector will be double in magnitude, but the direction will be opposite. Here we have a vector A with 2 units to the right and 1 unit upwards. So how will vector half A looks like? Yes, it will be half of vector A, and it will be 1 unit to the right and half unit upwards. What about negative half A? Yes, it will be the same as vector half A, except that it will be in the opposite direction. And what about vector 2A? Yes, it will be double the magnitude of vector A, and we will have 4 units to the right and 2 units upwards. For negative 2a, it will simply be the same as 2a, except that it is in the opposite direction. In the grid below, we are asked to draw the vector 2u minus v. So 2u will be double the magnitude of vector u, and negative v will be the same magnitude as vector v in the opposite direction. We put it in this way so that we have a continuous path in order to get the resultant vector 2u plus negative v, which is the same as 2u minus v. We can also draw the vector negative v here, so that once again we have another continuous path, and we will have the resultant vector as negative v plus 2u. And you notice that once again this is the same as 2u minus v. Let's look at an example here. In this diagram, vector OA is equals to 2a, vector OC is equals to 3c, OABC is a parallelogram, and D is the midpoint of BC. Here, the line BE and OC produce intersects at the point F. What this means is that if we extend the line BE and the line OC, these two lines will meet at point F. We are also given that BE is equals to 1/3 of BF and 2OC is equals to OF. It seems like a lot of information here. Let us break it down by representing all these informations onto the diagram. Vector OA is equals to 2a, and hence we will draw an arrow here pointing from O to A, and we will write down the vector 2a. Vector OC is equals to 3c, so likewise we'll draw the arrow and we will write down 3c. Since OABC is a parallelogram, therefore the opposite sides have the same magnitude and direction, which means that AB is the same as OC, and this will give us vector 3c. Once again, we will draw the arrow similar to OC. Vector CB will be equals to vector OA. Since D is the midpoint of BC, if CB is 2a, then CD is A, and DB is also A. Now this information here simply means that OCF and BEF are straight lines. Now BE is equals to 1/3 of BF. If we divide both sides by BF, we will have BE over BF is equals to 1/3, which means that the ratio of BE is to BF is 1:3, and ratio of BE is to EF will be 1:2. Finally, we have this information of 2OC is equals to OF, and if we divide both sides by OF, after which we will divide both sides by 2, and we will get this. The ratio of OC is to OF will be 1:2. Therefore, the ratio of OC is to CF is 1:1. Which also means that if OC is 3C, then CF is also 3C. Once again, we will draw the arrow to indicate the direction. Here, we have represented all the information onto the diagram. Here, we are asked to express vector AC in terms of A, N, or C. Now, vector AC is equals to this, whereby the two letters here must be the same. So, which letter will this be? For vector AC, we can use the vector addition of AO plus OC. Likewise, we can also use vector AB plus vector BC. Using vector AO plus vector OC will give us negative 2A plus 3C. Here we are going in the opposite direction as OA, and hence AO will be negative 2A instead. Next, we are asked to find vector BF. Now, vector BF can be written as this. Now, which letter should this be? Yes, we can use vector addition of BC plus CF, since BC and CF are both found. And we will have negative 2A plus 3C. Now, this answer here is equals to vector AC. And both of them are negative 2A plus 3C. What this means is that vector BF and vector AC are both parallel and they have the same magnitude because they are equal vectors. Next, we are asked to find vector OD. And vector OD will be equals to this. Now, which two letters will this be? Yes, we can use the vector addition of vector OC plus CD, since once again these two vectors are already found, and we will have 3C plus A. To find vector OE, we can use this vector addition, and the missing letter here will be the letter, yes, F. However, you'll notice that vector FE has not been found yet, and therefore we have to find vector FE first. Just to recall, previously we have already found vector BF to be negative 2A plus 3C. So how do we find vector FE? If vector BF is negative 2A plus 3C, then vector FB will be the negative of these vectors, which will give us 2A minus 3C. The ratio of FE is to FB will be equals to 2:3. If we multiply FB on both sides, we will have vector FE is equals to 2/3 of vector FB, which will give us 2/3 of 2A minus 3C. And hence we have already found vector FE. Now vector OF is equals to 6C here, and vector OE will be the addition of these two vectors. Simplifying, we will have 6C plus 4/3A minus 2C. Simplifying once again, we will have 4C plus 4/3A. And that's all for this topic.